Assalamualaikum and hi. So today we're going to look at the new subtopic 7.4 properties of waves. There are few learning objectives in this subtopic. The first one is to define wavelength, to define and use wave number, to solve problems related to equation of progressive wave y x t is equals to a sine omega t plus minus kx, to distinguish between particles vibrational velocity and wave propagation velocity, to use the particle vibrational velocity, to use the wave propagation velocity, and finally to analyze the graph of y versus t, which is the displacement versus time graph, and also y versus x, displacement versus distance graph. Okay, what is mechanical wave? Mechanical wave is a wave that needs to travel in a medium. Maksudnya, any types of mechanical wave kena ada medium untuk dia travel. The wave must have a medium. Examples of mechanical wave dekat sini adalah water wave, wave in rope, sound wave. So berdasarkan apa yang Miss bagi contoh dekat sini, you could assume the medium here dekat sini untuk water wave travel, medium dia adalah water. Untuk wave in a rope to travel, the medium here is the rope. Dan juga sound wave, the air here is the medium. Maksudnya kena ada medium untuk wave ini, gelombang ini untuk travel from one point to another point. Okay, apa beza mechanical wave dengan harmonic motion di mana you also learn about a periodic oscillation. Betul tak? Apa beza antara dua ini adalah you have, let's say for example, awak ada pendulum. Apa jadi adalah you pull the pendulum to this particular point to the right and then you release the pendulum. The pendulum is going to make an oscillation to the left and then come back to the dia akan come back to the right. And this periodic motion is going to produce you a sinusoidal wave. Okay, kita akan dapat wave juga. Cuma, apa dekat sini adalah you have one particle, iaitu your pendulum is the only particle that is moving and making that oscillation. So, wave yang kita dapat dekat sini adalah due to that one particle which is your pendulum. However, bila kita tengok chapter 10 ini, mechanical wave, tak kira lah water wave ke, wave in a rope ke, ataupun sound wave itself, the oscillation that produce the wave dekat sini adalah due to many particles. Maksudnya kita ada banyak sangat particles dan semua particles yang wujud dalam medium itu akan menyebabkan the production of the wave. So for an example, kita ada water wave dekat sini. So ini adalah satu, this is your surface of your water. Sangat tenang. Okay, kita akan ada banyak molecule of your particles dekat sini. So kita akan ada molecule of water, kita akan ada molecule of water yang tengah duduk on the surface of water. So what is going to happen here adalah when you drop a stone on the water, apa yang akan jadi adalah the stone is going to disturb this one particle over here. So dia akan disturb kita punya molecule dekat sini. So bila dia dah disturb this one molecule dekat sini, apa yang akan jadi dekat molecule sini adalah molecule ini akan turun ke bawah, at the same time dia akan ada vibration. So that particular vibration akan influence the particles dekat sebelah dia, molekul-molekul dekat sebelah dia untuk also vibrate. So all this vibration now is going to lead to the production of your wave. So kita akan form circular wavefront keluar daripada outward of the point of disturbance. So bila kita sambung semua circular wave ni, kamu akan dapat this beautiful nice wave ini. Okay, what is happening here adalah the particles did not move. Okay, particle itu tidak bergerak. It's just that the particle, contoh yang kuning ni, dia start the motion di mana dia vibrate, dia akan causes vibration on the next particle which leads to the production of wave. Maka kita pun akan dapatlah bentuk wave yang macam dekat gambar rajah yang ini. Figure 1 ini. So what you have here adalah kita ada wave, yang hitam ini adalah production of wave. Kenapa the wave has been produced here adalah disebabkan oleh you have particles. All the particles here is going to vibrate and produce a wave. Okay. So next kita nak tengok pada terminology. Into we have amplitude, which is the maximum displacement. And then you have frequency, number of complete cycle that passes a given point per second. Di mana kita tahu frekuensi ni kita boleh dapat daripada equation of omega is equals to 2 pi f. And then you have period, time taken for the particles to complete one cycle of its oscillation, which you can also find using the equation omega is equals to 2 pi over t dekat sini. Alright, ataupun you can relate your frequency and also your period, di mana your period here is equals to 1 over f and also vice versa. Okay, and then next you have wavelength. Okay, wavelength is a term that you are very familiar with. Cuma ini benda barulah untuk chapter ini. So you have wavelength, the distance between two successive identical points on a wave. Okay, so let's say kita ada, this is my wave, this is my wave. So distance between two successive identical point, maksudnya kalau saya pilih titik saya sini, dari sini sampailah for me to come back here is one wavelength, lambda kita panggil. Satu wavelength from two successive identical point. Contoh saya nak pilih titik sini pula sekarang. Sama pula. Contoh saya pilih titik sini. So what is going to happen dekat sini adalah this one here is my one cycle. Okay. Alright. And then next we have, this is another new term here dekat sini. Kita ada wave number. A wave number is the number of wavelength per unit distance. Is a number of wavelength per unit distance. Maksudnya kita nak tahu berapa banyak wavelength kita boleh produce dalam that particular distance. So equation untuk wave number dekat sini kita relate dengan a wavelength, iaitu 2 pi over lambda. So the unit here becomes m negative 1 as 2 pi tak ada unit, is unitless, and then wavelength kita unit dia adalah meter. Therefore your k has a unit of m negative 1. Alright. Okay. Next kita nak tengok bahagian progressive wave. Progressive wave maksudnya the wave that is travelling. Dia wave yang boleh travel, yang akan travel. Ataupun dalam kata nama lain, dia adalah travelling wave. Okay. So you are going to have a new equation for your travelling wave such as y in terms of x and t is equals to a sin omega t plus minus kx. Okay, before we look deeper into this equation, kita roll balik the equation from simple harmonic motion di mana y is equals to a sin omega t in our simple harmonic motion, where y adalah kita punya displacement, and then the a here is the amplitude, maximum displacement kamu, omega is the angular frequency, and t is the time taken, ataupun kita nak tahu what is the position of your particles at that particular time. Your y here is in terms of x and t, di mana your y here is the displacement now. Y yang akan jadi displacement, and this displacement, to be more specific, is known as the displacement of particle. Displacement of particle from the equilibrium point. Okay, it is from the equilibrium point. So let's say kalau saya ada wave dekat sini, let's say if I have a wave here, this is my wave, and this is my equilibrium point. Ini adalah equilibrium point saya. Okay, it is any displacement ke atas ataupun ke bawah from that particular equilibrium point. Alright, so we are talking about this y component as our y sebenarnya dekat sini. Okay, and then next kita punya x dekat sini. Apa jadi kepada x adalah distance of the particle from the origin. So maksudnya x ni adalah jarak partikel kita dah travel from the jarak partikel kita duduk from the origin. So let's say this is your origin, ini origin kita. So how far is that particle from the origin? Ini adalah x kita. Kalau kita berbalik ke graf ini, dekat atas ni, saya cakap we have many particles dekat sini, betul? Many particles dekat sini. And then let's say I want to know a particle, katakan particle ini, yang kita tengah cakap adalah this is the particle. Okay, this is the particle. Particle yang saya shade dekat sini. So particle sini sekarang dia tengah berada pada jarak x from the origin. This is what we call as the x tadi, distance of particle from origin. It can be any particle. Dia boleh jadi partikel mana-mana pun. Katakan partikel sini pun tak ada masalah. So ini adalah jarak dia daripada origin itu. Okay. Whereas bila kita cakap pasal what is that called? Y tadi, y adalah distance moved by the particle from its equilibrium position. Initially semua particles itu akan duduk along dekat sini. Dia duduk dekat sini. Macam dalam gambar raja ini. Tapi disebabkan oleh disturbance on one particular point, dia akan vibrate, dia akan turun ke bawah, causes vibration, menyebabkan pergerakan pada setiap objek. That is why
objek yang particles yang kuning ini, let's say saya panggil A dekat sini, dia initially it was sitting on this particular point. Tapi sekarang due to that vibration dia dah naik ke atas. Pergerakan dia adalah atas bawah saja sebab dia tengah vibrating. So this one becomes your Y, which is the distance moved by the particle from its equilibrium position. Sebab your particle is not going to move kiri kanan. Partikel itu akan duduk dekat tempat yang sama, cuma dia vibrate atas bawah. That formation of atas bawah itu yang leads to the production of your wave. T dekat sini adalah at a particular time lah, time taken lah. And then we have next, kita ada dekat sini adalah A. A is still the amplitude, iaitu maximum displacement of your particle, which is going to sit on your Y component here. Ini adalah A kamu, dan juga negatif A. Sin is the periodic motion ataupun sinusoidal waveform by the wave. Omega dekat sini is still the angular frequency. And then K dekat sini is the wave number, yang terminologi yang baru kita belajar tadi. Wave number which has a unit of m negative 1 tadi. And as you can see dekat sini, your omega is related to the time and your wave number is related to the distance. Alright. And then kalau perasan dalam equation ni kita ada plus minus. This plus minus has a meaning such as, kalaulah equation kita dia jadi y is equals to a sin omega t plus kx. Okay, what does this plus here means? That your wave is travelling to the left. Maksudnya wave tengah travel ke kiri. Alright. Kalaulah dia adalah minus pula, what does this minus indicate here adalah the wave is travelling to the right. Okay. So plus minus dekat sini tengah indicate the direction of wave travelling ataupun the direction of wave propagates. Positif maksudnya ke kiri, negatif maksudnya ke kanan. Okay, next we're going to look at the velocity for mechanical wave. There are two types of velocity for mechanical wave. One is particle vibrational velocity and another one is wave propagation velocity. Okay, what does these two velocity means are, when you have a wave being produced due to this mechanical wave, what is going to happen that this is the shape of your wave. Let's say I choose a point, which is indicating that we are choosing a particle. This particle is going to experience one velocity, which is known as velocity of the particle. The particles is going to vibrate and produce a velocity, which we called as velocity of particle. At the same time, this particle and also the other particle that present in the wave is going to, that is present in the medium, is going to produce the wave. Thus, the wave is also traveling and we are going to have velocity of the wave, which we call as wave's velocity. So, there are actually two types of velocity. One is the particles and another one is the velocity. Your velocity of the particle moves in a direction such that up and down only, as it is going to vibrate up and down. And the velocity of your wave is traveling to the left or right depending on the direction of the wave travel. So, particle's vibrational velocity is indirectly the velocity of the particle. Wave propagation velocity is the wave's velocity in a simple term. Okay, so the equation here is given as, for the particle's vibrational velocity is similar to what we have studied in simple harmonic motion, which is we have two equations for velocity. One is with respect to time and also the distance of the particles. Another one is with respect to the displacement of the particles from the equilibrium point. So the first equation here is this one. V is equals to A omega cos omega t plus minus kx. And the next one is V is equals to plus minus omega square root A square minus y square. These are the equation for vibrational velocity of a particle. It depends on what information given. You can choose and use your equation. But usually we'll use the second one lah. It is very common to use the second one. Okay, if the question asks to find maximum velocity of the particle's vibrational or particle's vibration, the Vmax occur when the displacement is equals to 0. So when your V maximum occurs at y is equals to 0, the equation now becomes Vmax is equals to plus minus omega square root A square minus 0 becomes A. So this is what we have for V maximum. And then next, for waves propagation velocity or waves velocity, we have equations such that V is equals to lambda over T, where lambda is the wavelength, T is the period. Or, as we know, T is equals to 1 over F, we can simplify the equation or produce another equation from that understanding, where F multiply lambda is also gives you the velocity here. Okay, you can choose, depends on the question what is given. If you have period, you can choose the first one. If you have frequency, you can choose the second one. So what we have here is a progressive wave is represented by the equation y is equals to 20 sine 20 pi t minus 0.5 pi x, where your y and x in meter and t is in second. Okay, before we answer the question and look at to the question, first thing is I'm going to compare my equation here, equation in the question with the with the general equation, which is y is equals to a sine omega t plus minus kx. So what I have here, I can compare from here. My a is 20, my omega here is 20 pi, my k here is 0.5 pi, and my wave has a negative direction here, which indicates that it is traveling to the right. Negative in the equation indicates that it is traveling to the right. So now I can write all the information I have, such as a is equals to 20 meter, and then omega is equals to 20 pi radian per second, and my k here is equals to 0.5 pi m negative 1. This is the unit for wave number, and then the wave is traveling to the right, as the equation has a negative sign. Okay, now to answer the question, I'm going to read the question. We have the first question is to find the frequency. So the question asks to find frequency, and we know frequency can be found using the equation of omega, and we have omega in the question. We have already identified omega. And the next question B here, the question asks to find the amplitude, and we have also already found the amplitude by comparison. And then next, the question C asks to find lambda, which is the wavelength here. So lambda, you can find lambda using the equation of k, where you have k is equals to 2 pi over lambda. So you can find your lambda. K we have already managed to deduce here. And next, the question asks to find the period, t here. So once you have got your frequency, you can find your period. And then question E, the question asks to find velocity of wave. So we have looked previously for velocity. Equation of wave is, so you can choose V wave is F lambda or lambda over T. Both the value you have got, frequency you have, period you have, wavelength you also already found in your question C. And then lastly, question F is the maximum velocity of the particle. So the question is asking the velocity of particle, but the maximum. So we know V max occur when y is equals to 0. So you can use this equation, plus minus omega square root a square minus y, to find the maximum velocity of the particles. So now I want you guys to complete the question and other question related to this.